thus far in our application, we have the ability to generate a secret random number, which in the development environment we're showing here. And we have the ability to read what the user inputs. Okay, so if they type in something, we know what they type in because we're storing it in memory. So what we need to do now is we need to compare the secret number to the number that the end user entered. And then we should order it. So what I mean by ordering is that if the secret number is 2 and the user gets 1, then we need to tell them that their number is smaller than the actual secret number, right? If it's greater, then we do the opposite. So we can either code that out ourselves, or I wonder if the Rust standard library would have something like that for us to call on already. So let's see. So let's try typing in. By the way, this is the standard library documentation. Let's try the keyword compare. See what we get. Well, we're getting way too many. That just confuses me. Let's try ordering. See what we get back. Okay, this looks promising. And ordering is the result of a comparison between two yada yada yada. Let's click on this, see what we get. Oh yes, and ordering is the result of a comparison between two values. That sounds like exactly what we need. Okay, so here's a variable and it's comparing is less, equal to, or greater. Yeah, that sounds like exactly what we need. And this little helpful enum up here. So for the time being, just know that enum stands for enumeration. It's essentially an object to hold multiple values. In this case, less than the comparator, equal to, or greater than. Okay, so this is something that we can certainly import from the standard library to use in our application. Let's do that. Since it's coming from the standard library, we can just call it here. So I'm grouping whatever is from the standard library together in alphabetical order. If it's from a crate, and I would group that with other crates and list it in alphabetical order. The reason for that is because when you have like a dozen of these, it's easier to read them to see what you have imported if they're in some sort of order. There's some sort of taxonomy there for us, for the brain to recognize quickly. Okay, so now that we have the comparison and ordering trait imported, I wonder if, so essentially what we need to match what the user enter to the secret number that we have here, right? In addition to the comparison. So I wonder if Rust has some sort of matching operator. Let's go back to here, find match. Oh yes, the match keyword. Control flow based on pattern matching. Oh look, there's a whole bunch of documentation on match. For example, match a number. Alrighty then. Let's try that out. See what happens. And from based on the example, we don't have to import anything in. We just use the keyword match straight out of the box. So guess this is the CMP trait from up here. And what do I want to compare? Right? I want to compare the user's guess with the secret number. Okay. So you haven't seen this syntax yet. For the time being, let's just say that it's designed to group a bunch of lambda functions together. Again, since I'm calling CMP here, we have the functionality from ordering here. And the syntax, you remember quickly, I know we only looked at it briefly, but the syntax, the documentation shows me the syntax. And it gives me hints here as well. You read through that. So if it's less than, I want to print line guess it's too low. Okay. Okay, as you can see here, I am getting an error here. Let's see what the error is saying. It says mismatch data type. Mismatch data type. What's that? Well, if you recall from the previous tutorial, we said that secret number implicitly was assigned to the int32 number, 32-bit integer, right? But if you look at the guess, it is a string type. So it's telling me here that, hey, you're comparing a string type to a number type, and that's just not kosher. Okay, so we have to fix this. Okay, so fortunately, Rust has a built-in concept called shadowing. Now, if you have some programming familiarity in other languages, you can also say that it's ability to cast data types. So what I'm doing here is called shadowing, okay? Meaning that I can sort of recast this guess from string to an unsigned 32-bit integer, meaning all positive numbers, right? So remember when we learned how to comment? Let's say that we are working on a team where we're switching from, say, JavaScript to Rust, okay? And everybody's new to Rust. So now would be a good time to leave a comment for ourselves and for our teammates. So let's just type in something simple like shadowing. And I encourage you guys to read documentation on Rust shadowing. Okay. Okay, so what I'm doing here is I am shadowing or recasting this guess variable to a unsigned 32-bit integer. And because we're taking input from the command line, we should trim off whatever white space there is on the end to include the carriage return. And then parsing essentially is another way to ensure that we convert the string to a number. In this particular case, we're parsing that string for a number. And then the expectation, again, I mentioned this earlier, but it's a way for Rust, built-in way for Rust to handle errors. And for the time being, just know that when things go right, we expect the guess variable to contain the guess from our input. Okay. Now, if the end user typing something that they're not supposed to type in the console, then the expectation would that we would throw an error, and then this error would contain this message here, and the message is user defined. It's engineer defined, right? So I'm typing this input must be a number. Okay, and then the error went away. Okay, so let's go to the terminal. Let's go to the terminal and see what we have. Let's run this. I'm gonna clear this out, and let's do cargo run. Okay, we get our welcome message. So we're cheating here, and we print out the secret number. So let's say I guess a number that's below the secret number. So let's say 1. Your guess is 1 and it's too low. That's correct because it's lower than 4, right? Let's run this again. Let's say 67. Too high. Okay. Let's try to run this one more time. Actually, 2 more times. Let's say I give them the correct guess. Secret number is right there is 1. Let's type in 1. Okay, exact match. We win. One more time with it. Let's say I put in my name. Okay, there we go. I know this sounds scary, but that's just part of the flow of the language. It's throwing an error. So this input must be a number, right? Just like in the expect statement when things go wrong. Okay. Okay, so now we have the ability to compare the secret number with what the end user type in and then give them the appropriate message. But as you can see there in the console, the program is stopping every time that we enter something. So we need some sort of mechanism to keep this going until the end user gets the correct number. Okay, we might be able to solve this problem with a loop. So the next episode, we'll work on loops. Thanks for watching. See you next time.